Hey guys, so this video we're going to talk about shapes and forms as it relates to hard surface. So this one you're going to learn quite a bit when it comes to designing your own things, but we're going to start in 2D and we'll be playing around in Blender as well, doing some 3D. But the basic idea here is that you have two distinct categories, but they're kind of the same. So shapes, right? So we're going to start with those and forms as well. One is the other, kind of in a way, they're related. But basically, I think we all know shapes, triangles, circles, squares, things like that, right? And then forms, of course, will be something a little bit different. They're going to be like cones and spheres and also cubes. So shapes are 2D, forms are 3D. That's the main takeaway here. All right. Now, one can become the other very quickly, especially when you're working in 2D. So here's the thing. If you were to take a triangle, for example, and lay it out and you extruded it in something like Blender, you would end up with, something like that, right? You could do the same for a circle, perhaps, and create a cylinder, or it could represent a sphere, perhaps. Okay, and the same thing would happen with a square. So you just extrude them, and they end up becoming forms. And so forms you can represent as shapes if you look at it from the left, the right, the top, the bottom, whatever angle you look at it from, creates a silhouette, right? And that's going to be your shape. So a cone, for example, could become a triangle. If you looked at it a little bit from the top, it would look something more like this. But if you looked at it all the way from the top, it would be a circle, right? And so, a sphere is probably going to be a circle, generally speaking, unless you got more detail on it. But a cube, of course, will become a square, unless you looked at it from an angle, and then it may look like something like a hexagon. So they're kind of related. They kind of go back and forth. You have to get used to working with these ideas. And so if you're doing isometric drawings later on where you're not using perspective, everything's parallel, your shapes become forms potentially, right? And it's exactly what we just did basically. All right. Now, here's where it gets fun. There's all kinds of shapes you can make. They don't have to just be those simple shapes, but we're going to start with some other simple shapes. A rectangle. I think a lot of us know what this is. When you skew a rectangle, it becomes a trapezoid, right? And so there's all kinds of different ways you can skew them, right? You can do like long edges. I forgot the names of all these, but basically, there's all kinds of different ways you can skew a rectangle, end up with different kind of looks to it. And this one's kind of important because you've seen this before. Matter of fact, if I do one real quick and we combo it up with some other skewed rectangles, right, we'll end up with something like this. And if you don't know what this is, let's go over to Blender real quick. We'll create a plane. Take something like this and inset it. You see what this is? When we take these three and we inset these and press I, suddenly we've created those shapes, or now turned it into a form. So later on, you might bevel something like that, and you end up with some nice looking kind of sci-fi stuff going on here. Just simple geometric shapes, basically. Nothing too crazy there to think about. All right. And so there's other shapes you can create that you might want to create anyways, like something like this, all right? Or like here, think of it like this. You take a triangle, right? And you split it. So you send it out in both directions. It'll end up creating a rectangle and you'll get the trapezoid. Okay. Possibly. You could add a little extension there if you wanted. So you can start cutting things like this out, perhaps, right? So you're starting to play with shapes and designing different kind of combinations of shapes. And this is important when you're doing sci-fi stuff, basically. That's like the main thing here is that's what happens. So if you had you done the same with like a sphere, right? Send it out in both directions, cut it in half. You'll end up still with a rectangle in the middle, but you'll have a half sphere, right? And a half sphere. And so if you only did one side, you'd end up with like the basketball court thing. But if you go ahead and you can draw circles through them as well. See where that's going? You get the pill shape though, so you can get pills as well. And as a 3D object, that's two spheres, obviously, right? Combined together. And so in the middle, instead of it creating a rectangle, it would be maybe a cylinder in the middle, right? That's the idea, anyways. So you play around with these over and over and over again, and before you know it, you can create all kinds of interesting kind of shapes and designs. And you start taking into consideration from the last video, the form and design video, where you have different percentages. And so now you can do, things at percentage base, or you can skip doing like a cut in there maybe. And then maybe this one comes out here. And you start seeing how this all can be related with each other, perhaps, right? Maybe you want to do some things like that. Okay. Or you could think of it as taking like a trapezoid and maybe you cut off the edges, right? There's actually a name for this when it's a form, right? Something like that. You could do a triangle, cut off its edges as well, or its corners, should I say. We'll end up with something like that. Now, you don't have to just cut them off. You can, of course, can round these things too. You'll end up with a nice little detail here, perhaps. And then you start comboing this up with other ideas. Remember that form and design video I was talking about, you can do on an edge, you can do like center alignment, you can do right alignments, left alignments, things like that. So when you start looking at things like this, you could do like an inset of sorts, like a small detail inside here, perhaps. But on the edge, maybe you do some center aligned cubic cuts, maybe make the one at the bottom a little bit bigger. It's a little bit rough looking at this, but I think you get the idea here. It's too small. But I think you get the idea. And then maybe these have some bolts or screw holes in the corners. So now you're comboing shapes together. Okay. So this is what you're missing when you're trying to design things more than likely and getting flustered by the idea of doing hard surfaces is that all of these little things take place. But just as we were cutting these edges on these shapes, perhaps we can do that with 3D shapes as well. So think of it like this. If you have maybe like a flat surface here and it bevels, right? And we bevel this corner, we bevel this edge, and it wraps around like this. And so if we were to take this curve here, and imagine that we're doing a boolean with like a cube in Blender. We'll actually do this in a sec, but let's say we're doing a boolean right here across this area. And what we'll end up doing is flattening that area out basically. And so that would run flat all the way to wherever it starts to deviate in the curvature of the shape. So this would be still flat over here, perhaps. Okay, and because it's starting to deviate here, you actually have like different little ways this runs out in this area. But basically, it creates something like so, something around there, and that's how you get those kind of interesting designs like that, perhaps. And then later on, you can think about maybe, yeah, maybe you want a triangle here, right? But you don't want to make it a perfect triangle. You want to make it a beveled one, maybe. And so we end up with a nice little detail there. And so comboing this up with all kinds of other ideas is where you're going to start to take off, I think, because there are some manufacturing processes you need to keep in mind, perhaps. So a lot of times you have these cutaways in surfaces. Okay, let me see if I can draw a line all the way through there. If not, I'll use the line tool. Okay, and a lot of times you have these little cutaways in surfaces, and they remove material. Okay, and so this whole area might dip down a little bit lower. It might dip down a little bit lower here. And we'll start getting something like this going, perhaps, or close to that, anyways. And so this has become subtracted from there. This is more rigid because of this design. And this is more of like a weight reduction material removal process that takes place. And so it just keeps the rigidity of the shape, but it removes excess weight, basically. Something along those lines, anyways. Or it reinforces the shape itself so it doesn't flex under load and things like that. And so what happens here is you got to think about, how the actual design might influence or like how the actual like mechanical needs of the object might influence its design as well, perhaps. Right? Like that could be a real thing you have to deal with because if it doesn't look right, it's not as believable. So learning about some manufacturing processes is important. Check out Wikipedia. They got a whole list of all the different processes there. So like there's casting, there's machining, there's welding. There's all kinds of other stuff in there, 3D printing included. But basically, keep those things in mind. Now, designs usually start, at least 3D designs usually start in a CAD program because they need to be turned into real world things a lot of times. And CAD programs will tell you if you can set it up so like you're using certain materials with certain types of manufacturing processes. They'll tell you when you can and can't do things, or if something's going to cause an error or a bad design a lot of times. And so you can think of like a bevel here, okay, and we have two planes coming out of it. And then if we make that a form, of course, it's just maybe extruding, right? So like brackets and hinges and things like that. Now, if this was just a solid metal piece of aluminum, it might be cut up using machining, perhaps. In machining or drilling, you could possibly put a hole here, right? That's a real possibility. You just work out a hole there. But if you're going to bend a shape like this, where it starts flat, and our bend would take place here, right? And then you start bending it, you can't put a circle there because what ends up happening is like if it was existing here when it was flat and it bends, it's going to create like an elliptoid. And that's not going to be proper. All right. And that's not something they want to do. So there's actually a distance that must be traveled backwards until that will maintain its actual shape there. And is dependent on the depth of the metal. So little things like that, you don't necessarily have to know them, but they can be quite useful whenever you're creating designs, right? Like think about how the thing was actually manufactured, and it will help you get kind of to that point where all of this starts to make a lot more sense, anyways, look more believable, and you can start making little changes here and there, doing center alignments, perhaps something you might want to do, and you can also make other little changes perhaps that like maybe we chamfer these to like these are in line with each other here, but it raises up just a little bit. And then now maybe we just do a pattern in here maybe. And so think about patterns and rhythms and flows as well. It's kind of an art fundamental, but basically the eye likes to latch on to patterns quite a bit. Okay. And so you can use dead space to represent like the alignment of things as well. Like we don't actually have any lines there, but we get the idea that could be. But you could always do like a small little like push in perhaps and do like some small surface details in these areas as well. Or if you want to go to the extremes with it, cut it all the way through perhaps and bevel inside there, something like that. So you can start seeing how these kind of ideas start to play out when you're working with 3D geometry. On the other hand, you're looking at forms that are still those basic ideas of shapes. So if you scale in the top here, you're creating more or less a trapezoid in all directions. If we were to bring it down, make it narrow, we do a bevel on it. We start with something like this. Perhaps may or may not like those corners. I personally don't care for them, but a lot of times it's better to manually bevel some things so you get something more like this. There's a kind of an order to bevels and Blender at least, and so you can start comboing these kinds of ideas up. So you can get different plane levels. Like this is a little bit lower, this is a little bit higher. Maybe this is twice as big as that one, and it sits behind it. And so now we're playing with shapes though, ultimately. This isn't like these forms are very simple in general, and you can tweak them. So if we remember there was different types of trapezoids right here, like there's different types. That's what a skew will do, basically. Or like if you were to just grab this face and move it, right? You can see like we can start moving it and making different kinds of trapezoids, basically. Yeah. So that kind of destroyed the bevel here. You can adjust the bevel angle sometimes and get it back. Sometimes it causes issues, but I think you get the idea there. So if you ever needed to do a boolean later, you can do like a cube, place it in a position, do a bevel here at the bottom, and do maybe like a boolean subtraction. All right, you'll see that one kind of caused a little bit of an issue here. More than likely, this is caused by um, it needs additional edges in it, perhaps, or the bevel is causing the issue. It's one or the other. Let's turn loop slide off, see if that helps. No, bevel smaller. Almost got it, not quite. Okay, so I'm gonna do a symmetrize with mesh machine where I put an edge down the middle, see if that helps. Nope. Sometimes you gotta do something like a KCA, and maybe you can cut across the middle there, and maybe that'll help. Other times it's a balancing act. Kind of weird how that happens sometimes, but it could be a balancing act as well. I think the bevel's just too big as well. There you go. Right. And so you might have some weird shading at the end. You add a weighted bevel or weighted normal modifier. Okay. And so you can do things like that. If you ever mess up on something like this and you're doing destructive modeling, get Mesh Machine for this specific purpose right here. You can use the refuse feature and you can do this number all day long. You'll see you can even change the tension amounts. So we can turn it back to a point 0.5 if we don't want to use point 0.7 perhaps. Point 0.7 creates a better bevel usually, in my opinion. It usually looks cleaner is what I'm saying. But if you wanted to refuse and do instead a point 0.7, you can change these things. So Mesh Machine is not always going to get things right as far as being able to unbevel and whatnot, but a lot of times it does pretty good, and so it's not too bad. Here's where it gets even more interesting, I think, is that we can combo these kind of ideas up one on top of each other as well. Okay, so it's just a floater right now, but you could definitely finish out the shape doing something like an extrude all the way down, perhaps merging it. So we could do maybe like a Boolean union, or let's see if we can do extruding up, pressing F, Alt N, recalculate outside. We should also be able to use this as a cutter, I think. And it might cut it right. It might go crazy. In this case, it went crazy. Because it might have a bevel on it that we don't need. We'll get rid of it. And this bevel also is taking place that we probably don't need it that large either. That's what I call the creep. Every time you make an adjustment, it starts going a little further and further. So we could just use the basically the backside of it. If we wanted to sink it in further, we could as well. Right. And that might be something you want to do or may not. I don't know. It's up to you. Grab the edges here on the corners, perhaps. Maybe give those a little bit of a bevel. All right. See that bevel's still causing an issue. Bevels on bevels on bevels, but yeah, this is why I do a lot of manual work and don't use these modifiers. Well, I still use them, but a lot of times I have to collapse them, and that's hit or miss type deal. Anyways, you can also try turning loop slide on and off. You'll see you get different results. Okay, it's going to be up to you whether you keep it on or off, basically. And you can always go back through and grab something if it's a little too complicated. Try doing X limit dissolve, type in 0.05. It may or may help you. It may or may not help you out a little bit when it comes to certain things like this area here. I wanted it to be a little bit cleaner, perhaps. And I'm going to turn loop slide off, and we can change the profile if we wanted as well. It's really up to you what you do here. And so, yeah, there you go. There you have it. You can make this kind of stuff super easily off of those basic ideas. Now, there are some limitations, though, I want to mention. Like beveling in this area on a flat surface might not be a big deal. Okay. If you're on a rounded surface, you're going to have to pay particular attention to these bevels and make sure these edges are going to work for you. But you might also just want to mix things up with chamfers as well. Okay. So don't maybe bevel everything, but maybe every now and then add a chamfer or whatnot and see how it works out for you. In this case, I think it's okay-ish, but I would much rather maybe change that bevel again back to loop slide, maybe. Oh, that doesn't do nothing there. Okay, so that's a little bit rough in that area. But we could tweak it, of course. So you're freely capable of working on those as you see fit, trying to work out your issues, right? Anyways, so yeah, that's pretty much it for this one. And hope you enjoyed the video. I'll check you out on the next one. All right, take care.